Roughly 257 miles above Earth, something about the length of a football field, including the end zones, is completing another lap around the planet. It is one of 16 orbits it will make today, as it has every day for more than 25 years. The International Space Station is the largest single object ever assembled by humans in orbit, built at a cost historians estimate at between $100 and $150 billion. Within the next several years, it will be destroyed, not by accident, but deliberately. NASA and its partners are not waiting for the station to fail. They're planning its end in advance, a controlled destruction aimed at the most remote stretch of ocean on Earth. That decision is tied to a warning that has grown more serious over the past 7 years. In September 2019, engineers detected a small but persistent air leak in a transfer tunnel connected to Zvezda, the Russian-built service module. The affected section is known as the PRK. For years, the leak remained manageable. It was patched, monitored, and tracked. A technical concern, but not an emergency. Over time, that changed. By 2024, the leak rate had increased enough for NASA's Office of Inspector General to identify it as a top safety risk to sustaining station operations through 2030. NASA's Aerospace Safety Advisory Panel went further in its 2025 annual report, describing this stage of the ISS's life as the riskiest period of its operational life. It pointed to resource shortages and micro-cracking as the most immediate concerns. The panel was also clear about the worst case. If the problem was not managed, the station could eventually become uncontrolled. That warning came into sharper focus on June 5, 2026, only weeks before this video. That week, Roscosmos observed the leak rate rising to 2 pounds of air per day, roughly double its previous level, and identified new areas showing signs of stress. As a precaution, NASA directed 5 crew members, including 4 SpaceX astronauts and NASA's Chris Williams, to shelter inside a docked Crew Dragon. Roscosmos said publicly that the situation does not threaten the safety of the crew and onboard systems. But both agencies agreed on one critical point: a proposed repair involving a saw and a load-bearing bracket near the leak was too risky to attempt. Roscosmos paused the work, and the crew returned to normal operations about 2 hours later. No one was hurt. But the incident showed in real time the kind of risk NASA's safety panel had been warning about for more than a year. Some of the station's oldest sections were built for a structural life of 30 years. By the time the ISS is scheduled to retire, those sections will have been in orbit for 32. The strain is beginning to show, and it is one reason the station's end is no longer a distant planning exercise. The decision to retire the ISS did not begin with the leak. It began, in fact, with math, and with a safety standard that leaves little room for improvisation. U.S. government policy requires that any spacecraft large enough to survive re-entry pose no greater than a 1 in 10,000 risk to people on the ground. At somewhere between 420 and 460 metric tons, the ISS is far too large to meet that standard if it falls from orbit uncontrolled. NASA's own analysis shows that, if left alone, it would re-enter within 1 to 2 years, with no way to guarantee where the surviving debris would land. NASA studied other options. Taking the station apart and bringing the pieces home was ruled out first. Building the ISS required 27 shuttle flights, 13 years, and 161 spacewalks, and no spacecraft flying today has the cargo capacity to reverse that process. Raising it into a higher graveyard orbit was also rejected. A stable, century-long parking orbit would require between 120 and 140 meters per second of propulsive force, compared with 57 for a deorbit burn. That is far more engine work than a station designed for gentler maneuvers was built to withstand. NASA also estimated that meaningful debris collisions, which occur on average once every 51 years at the station's current altitude, would happen more than 10 times as often at the altitudes proposed for long-term storage. That left one option: bring the station down deliberately, under full control. On June 26, 2024, NASA selected SpaceX to build the vehicle that will do it, a modified version of the company's Dragon spacecraft, paired with a reinforced trunk section carrying several times the propellant and thrust of a standard Dragon flight. The contract is worth up to $843 million for development alone. In an unusual arrangement, NASA will take ownership of the vehicle once it is built and operated directly. Ken Bowersox, NASA's Associate Administrator for Space Operations, said the selection would help ensure what he called a safe and responsible transition in low Earth orbit. What NASA is describing is, in effect, the most expensive controlled destruction ever attempted. A spacecraft built for one task with no expectation of surviving it. The question then becomes how something this large can be brought down safely, and where more than 400 tons of retired spacecraft will actually go. The answer, laid out in the most detailed public timeline available, a government assessment published in June 2026. This complex operation will unfold in stages, not in a single moment. Sometime in early to mid-2028, operators plan to begin lowering the station's orbit. First, they will rely on natural atmospheric drag. Then they will use engine maneuvers from the station's Russian segment. By mid-2029, the purpose-built deorbit vehicle under construction at SpaceX is expected to launch and dock with the station's Harmony module. It will almost certainly require one of the most powerful rockets available today, likely a Falcon Heavy, because the finished vehicle will be significantly heavier than any Dragon spacecraft that has flown before. Once the final crew has departed, controllers will use that vehicle to align the station's path and perform one sustained engine burn, sending it down along a precise, chosen track rather than leaving its descent to chance. NASA's current target for that final burn is the end of 2030 or early 2031. The reentry itself will also unfold in stages. NASA's transition planning describes a three-part sequence. First, the solar arrays and radiators separate. Then the modules and connecting truss segments come apart. Finally, as the outer structure heats to extreme temperatures, individual modules fragment and expose what is inside. From hundreds of kilometers along the flight path, it would look like an extended glowing streak crossing the sky, with smaller fragments trailing behind it, closer to a slow-motion meteor shower than a single dramatic instant. Most of the station is expected to burn away completely. But denser components, including gyroscopes, docking mechanisms, and the heaviest module nodes, are expected to survive the heat and sink into water more than 5 kilometers deep. The target is a place called Point Nemo in the South Pacific, the most remote point in any ocean on Earth, roughly 1,670 miles from the nearest land in any direction. There is something almost strange about that detail. At almost any given moment, the closest humans to Point Nemo are the astronauts aboard the ISS itself, passing 257 miles overhead. Since the early 1970s, Point Nemo has been used as a disposal zone for retired spacecraft, absorbing an estimated 250 to 300 vehicles, including Russia's Mir station in 2001. At roughly 130 tons, Mir was the largest object ever deliberately brought down this way, until now. The ISS, at more than 3 times that mass, will make this the largest and most complicated controlled re-entry ever attempted. This kind of precision has not always gone as planned. In 1979, NASA's own Skylab station came down short of its intended zone, scattering debris across Western Australia. That history is part of why so much planning now surrounds the ISS deorbit. Even the deorbit vehicle itself will not be spared. Built to fly exactly once, it is expected to break apart alongside the station it brings down and sink with whatever debris survives. It's worth saying plainly, though, NASA maintains that its own structural analyses still show a healthy safety margin, at least through 2030. This is not a station in uncontrolled freefall. It is, instead, a station approaching a deliberate, engineered ending on a timeline chosen years in advance. there is another detail in this story that rarely comes up, even among people who follow the ISS closely. It's worth pausing on. The first module of the International Space Station, Zarya, launched from Baikonur in November 1998, did not begin as part of an international cooperation effort. Its design traces back to hardware originally built for Mir 2, a Soviet space station concept that was never completed. Some historical accounts go further, suggesting that components inside Zarya originated from mothballed hardware built for a cancelled Soviet military program, a laser-armed satellite system known as SCIF. If that lineage holds up, then the first piece of what became the most cooperative structure ever assembled in orbit began its life inside a Cold War weapons program aimed at the same nations that would later help build and crew it. 25 years of continuous, peaceful partnership were built, quite literally, on top of it. Then the next question is, what comes after? NASA's long-term plan was never to disappear from low Earth orbit. It was to stop owning the outpost there. Government auditors say the station currently costs roughly $3 billion a year to operate, and NASA's own Inspector General estimated in 2024 that shifting to privately owned, commercially operated stations could save between $1.3 billion and $1.8 billion annually. Even NASA's approach to that transition has changed recently. In March of this year, the agency floated the idea of building its own government-owned module for companies to attach to. Then in June, after pushback from the aerospace industry, it reversed course and recommitted to funding independent, privately owned stations. Several companies are still working toward that future. Axiom Space, Voyager Technologies' Star Lab in partnership with Airbus, and VAST, whose first module is targeting an early 2027 launch. A partnership between Blue Origin and Sierra Space, called Orbital Reef, has also been in development, though its status has become less certain over the past year. Every one of these projects has already slipped from its original schedule, and reviewers inside NASA's Inspector General's office have said it is unlikely that any of them will be fully ready before the ISS retires. That uncertainty is the part NASA's own safety advisors have been most direct about. Government auditors have said NASA has not yet formally assessed how long a gap in continuous human presence in low Earth orbit might last if a replacement is not ready in time. NASA's safety panel went further, describing the broader transition strategy in one word: aspirational. Some in Congress have framed the stakes of that gap as a race against China's Tiangong station, which could become the only continuously crewed outpost in orbit if one opens up. That framing reflects one side of an ongoing policy debate, not a settled technical fact, and lawmakers remain divided on it. What is formally settled, for now, is less than it may seem. As of this recording, NASA's official plan still targets 2030 for the end of station operations, with final re-entry in late 2030 or early 2031. But committees in both the House and Senate have separately and unanimously advanced legislation that would push that date to 2032 and would legally prevent deorbiting the station until a commercial replacement has proven itself operational for a full year. Neither bill has passed both full chambers, and neither has been signed into law. The plan has also drawn scrutiny from outside government. Environmental advocates, including the Ocean Foundation, have pointed out that international law clearly requires compensation when space debris damages another nation's territory, but includes no comparable framework for debris landing in international waters. The Foundation's president, Mark Spaulding, has called this a troubling structural gap in international law. NASA's position is that the vast majority of the station will burn up completely, and that what survives will mostly be inert metal, unlikely to pose significant chemical risk once it settles on the ocean floor. Alongside the engineering and the politics, something quieter has also been happening. At a space industry conference earlier this year, NASA officials and museum curators, including representatives from the Smithsonian, met to discuss what should be preserved before the station comes down. Not the structure itself, which is too large to bring home, but smaller pieces of it. Onboard journals, instruments, and fragments meant to be shared rather than left to burn. For more than 25 years, the International Space Station has never once been empty. Whatever happens to the timeline between now and its final descent, that unbroken human presence, continuous since November 2000, is the part of this story that shaped everything else about it. The ending, whenever it arrives, is already being planned around preserving that legacy.